In this video, I'm going to talk about IXL I.3. It is about simplifying variable expressions involving like terms, and we are also going to use distribution property somewhere in the middle of the video. So I'm probably going to solve 6 or 7 questions, probably 7 questions in here. I will solve 1 question per each level up until we make it to like either high 80s or 90. Okay, the first one is simplify. It says simplify the expression. I think that's going to be the question for all of the rest of the questions. So what we do is we look for the we look for like terms and then we combine them together. So in here, each one of the terms have the variable a. That means they are all like terms. We have 7a plus 9a minus 10a. So in this case, you can combine the numbers in front of them. 7 plus 9 minus 10 would give you 6. And then you keep the a because we have 6 of this. So the answer to this one would be 6a. Probably many of you would get this one right without any assistance. Let's move on to the next level. Now we need to distribute this for ones. Remember the order of operations. First, if you have anything inside parentheses. By anything, I don't mean monomials. They don't count. If you have only one term in parentheses, there's nothing that you can do about it. But in here, you have 2 terms. Okay? If you can combine them, you need to combine them together. One has p, the other is just a constant, a number. So in that case, what we have in the parentheses are not like terms. That means we cannot combine it. So there's nothing that I can do about what I see inside the parentheses. But I can multiply these two and then these two. That's what we call distribution property. Let me just redo that part. 9 times 8p is the first thing. Whatever you have outside of the parentheses, you multiply that term or number by whatever you have in the inside of the parentheses, one at a time. So 9 times 8 is 72p, keep the variable, and then 9 times 5. 9 times 5 is 45, and then it is positive because 9 is positive, 5 is positive because of that plus 5, so it is plus 45. And then in the end, now there's no parentheses because I got rid of it, plus 3p. Now at this point, you need to still look for like terms. Like, do you have any like terms? Are there more than one term that has a p or that has just numbers? So right here, we have 72p and then we have plus 3p. Those are like terms. We can combine them together. Do whatever the numbers in front of them tells you to do. This is positive 72. That one is plus 3. Add them together, you have 75. And then both of these terms have p. And then I have just a constant. So this right here is called constant. If it's just a number without a variable, it is called constant plus 45. You just bring it down. There's no other number that you can combine with 45. Now, these two are not like terms. That means this is your final answer. If you cannot put them together anymore, that you are done. So 75p plus 45 would be the answer to this question. Let's move on to the third one. Question number 3. We have 3 terms, and all of them are like terms. In one of last week's assignments or the week before, one of the assignments was about polynomial vocabulary, which one part of that assignment was how many terms do you see in here? How many terms do you have here? So we are using that knowledge to solve this one. So we have 3 terms and all of them are like terms because they all have x in it. We don't have a constant here because each term has an x. 9 plus 10 is 19, plus 7 is 26, so this one would be 26x. We don't want to write an exponent because when we add them together, we are not going to increase the power. We don't make it look like x squared or x cubed. That happens when you multiply a variable by itself more than once. So that would be the answer to this one. Let's move on to question 4. Okay, now things are getting a little complicated. We have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 terms are either added or subtracted. That's the definition of terms, the things that we add or subtract in an expression. Now, if you realized all of these have a variable, each one of these numbers, right next to them, there is a variable which is t squared. Since they are all the same, it's not like some of them are t squared, some of them are t or t cubed. They are all the same. It's t squared. But how many t squared do I have in here? I have 5 plus 3. These two makes an 8. Minus 3, my bad. Minus 5. 8 minus 5 is 3. Plus 9 is 12. Minus 9 is 3. Plus 1, because this is 1 t squared, it would be 4t squared. Okay? And then if you hit this button, you'll be able to type an exponent and the variable. You would use your keyboard. I don't want to... Let's just do it then. I think you can figure that part out anyways, but 4t would be the bottom, and then you would put your exponent in there using your keyboard or whatever tool you have. You would type 4t squared in there. Again, all you do is just combine the numbers in front of them, like 5 plus 3 minus 5 plus 9 minus 9 plus 1. Don't forget about this plus 1, please. If you see just x squared, m squared, n squared, it means there's only one of them. And if you don't put it in there, you may forget about it. So please remember that if it just says t squared, it is referred to 1t squared. Now, and when you combine all these numbers together, and here is a shortcut. Positive 9, negative 9, they cancel each other out. Positive 5, negative 5, they cancel each other out. And all we have is 3 plus 1. When we combine those together, we get 4. And then the variable was t squared. That's just another way of doing it. If you don't want to just count them all together, you can make a list, cancel out the ones that have the same number, different signs. Okay, moving on to the next question. I think this is question number 5. Combining the like terms. If there are no like terms, rewrite the expression. So if you end up with something like this, if this is your question, and if it says simplify it or combine the like terms, you keep it the same. This would be your answer. If this was your question, your answer would be the same because there's no like terms. You need to rewrite this whole thing as your answer as x plus 3. Just keep that in mind in case you have such a question. But in here, we have 3 terms, and each one of them are like terms because they all have the same variable, r. It's not r, I was going to say r squared. So 8 plus 6 is 14, plus 5 is 19. Keep your variable the same because we are not multiplying them. When you add or subtract, you keep the variable the same. Moving on to the next question, combining the like terms. If there's no like terms, keep it the same. Okay, now I have 3 terms in here. Let's see if the variables of these are exactly the same. This one here is g h cubed, right? G times h cubed. And it's the same as that one, g times h cubed. And here it is g times h cubed again. That means these are all like terms. If I just combine the numbers in front of them with their signs, that's all I need to do. So let's just check that out. The first one is a positive 8. The next one is plus 6. And then minus what? Please make sure you do not put minus 0 in here just because there's no number in there. There is a number in there. It's 1. Because if I ask you this question, how many x do you see in there? It's just 1 x, right? But there's no 1 in front of it. It's up to you whether you want to put it in there or not, but you need to know that there's only 1 x, or there's only 1 a, or there is only 1 xy in here, or there's only 1 g h cubed in here. That's why it is minus 1, and when you do this, you get 13. The number you have is 13. Your variable is g times h cubed. Next question, and the last question. Combining the like terms. Let's see. Z squared. We have 3 terms. The first one has this variable, z squared. Do you see any like terms? There's no like terms. So we want to keep that the same. 24 z squared is going to be part of my answer. It's going to look like exactly like this because it doesn't have any like terms. I want to keep it the same. Now, let's focus on the second and the third terms. V squared x cubed, V squared x cubed. It's the same exact variable. So that means I can just combine the numbers in front of them. The first one is, I'm going to do this on the side, and then I will put that term right next to 24z squared. On the side, here we go, 19. And then, is that a plus 18 or minus? Okay, that's plus 18. And this was positive 19. That's why I didn't put a negative in front of it. So if I combine these two, I have 37. So, and there's no negative still. Plus 37. Keep the variable the same. W squared times x cubed. That would be my answer. So you would type it exactly the way you see it if you end up with the same question, but I don't think they keep changing the numbers. So yeah, that's all for this video, guys. We learned how to combine like terms in expressions. So let me know if you have any questions. Thanks for watching.